In this video, we're looking at section 5.2. This is where we really start looking at the definitions for the 6 trig functions, and we work a little bit on using those. So when you first get started, you generally look at the 6 functions, the 6 trig functions, and you get started using a right triangle when you do that. And so you have to learn, no matter what the orientation of the triangle is, you have to be able to identify the sides of the triangle relative to an angle that you're given. So let's say we designate this angle as the angle we're going to be focused on. I'm calling that angle theta. Then looking at that triangle, we see that C is the side opposite that triangle. So you've already done a little review of Pythagorean Theorem. And so you're probably already familiar with this. C would be the hypotenuse of the right triangle. Now, A and B, they're the legs of the right triangle. But what we need is to identify which one is opposite theta and which one is adjacent to theta. So side A, that's going to be the opposite side because it's across from angle theta. And side B is the adjacent side. Now, sometimes people get mixed up with adjacent and hypotenuse because they're both forming angle theta. But the hypotenuse is the longest side of the triangle. So get it out of the way first. And then it's these two shorter sides that are either the opposite the angle or adjacent to the angle. Okay. So we're going to use those labels. We're going to focus on angle theta where I put it. And we're going to define the 6 trig functions. Right. So sine, cosine, and tangent. These guys, these 3 right here. Okay. These 3. All right, are the basic trig functions you really need to know. And so when you're looking at those, sine takes the ratio of the side opposite divided by the hypotenuse, the length of the opposite side over the hypotenuse. Cosine is the length of the adjacent side over the hypotenuse, and tangent is the length of the opposite side over the adjacent side. All right, just those 3 right there. Some people remember those by using a mnemonic device, Sohcahtoa, and it's important you spell it right. Sohcahtoa. So you see how sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Right, and then sometimes people will write it, so they show the ratio and that kind of thing. They have like fancy ways of writing it, but basically you have to associate opposite with sine, adjacent with cosine, and then make sure on tangent, that's the one that has the opposite over adjacent. All right, now look for a moment at the trig functions that are next to each of those. Okay, I've got these lined up so you notice this relationship. See how cosecant is just sine, the sine ratio flipped over. It's the reciprocal of the sine ratio. And then secant is just the reciprocal of the cosine. All right. And cotangent and tangent are reciprocals of one another as well. So once you know the original 3, then you just take the reciprocal of those to get cosecant, secant, and cotangent. Okay. Now notice also that sine goes with cosecant. See how the letters are different? And that cosine goes with secant. So don't put sine and secant together. Secant and cosine are related. Sine and cosecant are related. All right. Also, I want to go ahead and write out the actual names of these. You only see 3 letters on your calculator: sine, cosine, and tangent. But sine is actually S-I-N-E. Cosine is C-O-S-I-N-E. Tangent function. Then over here we have cosecant, and then this is secant, all right, and then this is cotangent. Okay. All right, so now if we go back to our original triangle and we write the ratios in terms of these little letters, which represents the lengths of the side, then sine of theta would have been A over C, because A is the opposite side to theta. Okay, this one would have been B over C, and this one would have been A over B. And then when you go to do cosecant, you flip over, it's the reciprocal of sine. So it's C over A. Secant is C over, oops, did that wrong? Yes, no, that's okay. C over B. And then cotangent is B over A. Okay, so keep looking and making these connections between the definitions of the different types of functions, okay, because we're going to work with these quite a bit. All right, now one of the ideas I want you to kind of have in the back of your mind is the value of a trig function, the value of sine, cosine, or tangent doesn't depend on how big the triangle is, and later we'll be working with circles. It doesn't depend on how big the circle is. It just depends on the size of the angle. So they depend only on the size of the angle, okay? Not on the size of the triangle in this case, okay? In other words, you could have, a bigger triangle that had sides in the same ratio. And so you don't focus on the size of the triangle. You're focusing on measuring the angle itself. All right, let's go ahead and take a look at two examples. Now see on these two triangles how you only have two of the sides of the triangle. So this is part of the reason I wanted you to work with the Pythagorean theorem last time, because you need to identify the third side of these triangles. So that's the first thing you're going to be doing, is looking for the third side of the triangle. So we're focused on what is this right here. Okay, so I'm just going to let that be an X for now. So you have to notice that X is the longest side. It's the hypotenuse because it's across from the 90-degree angle. So when you do set up your Pythagorean theorem, you'd have your 8 squared and your 15 squared added up equal to the X squared. All right, so X squared would be 64 plus 225. And it turns out to be 289, which just happens to be a perfect square. Sometimes you'll get a perfect square, sometimes you won't. And you'll have to simplify your radical. So when you take the square root, you get plus or minus the square root of 289, which is plus or minus 17. And then in this context, only the positive one makes sense. So X is equal to 17 right here. All right, now, before we can answer what I'm asking you to do on question number 1, we have to focus on a particular angle. So let me go ahead and say, let's make angle theta this angle, okay? Now we're being asked to write what the ratios would be for the 6 trigonometric functions. So you have to focus on where your sides are relative to theta. First off, we know 17 is the hypotenuse. And then 8, see how it's across from theta? So that would be the side opposite, and 15 would be the side adjacent. So keep that in mind, and keep in mind that's Sohcahtoa. Okay, and I would go and do sine, cosine, and tangent right off the bat. Okay, so sine should be 8 over 17. Okay, cosine, that would be 15 over 17. Okay. And then tangent would be opposite over adjacent, so that would be 8 over 15. Now, sometimes you have to do some simplifying, but in this case, there's no common factors in the numerator and denominator, so you can't really simplify any of those. Now, when you go over to do cosecant, secant, and cotangent, if they're organized the way I've organized these, sine and cosecant are reciprocals of one another. So it's going to be 17 over 8. Okay, this would be 17 then over 15. And on cotangent, it's going to be 15 over 8. Okay. All right, now, on problem number 2, we are missing a side here, but it's not the hypotenuse. It's one of the shorter sides. So we're going to need to use the Pythagorean theorem, and let me see if I can get it worked out right here. So we have x squared plus 1 squared equals 5 squared. So x squared would wind up equaling 24, wouldn't it? See how that would be 25 minus 1, so that'd be 24. So x would wind up equaling plus or minus the square root of 24. So you have a little work to do simplifying that. 24 is 2 times 2 times 6. So 24 can be simplified into 2 square root of 6. Okay. So it's plus or minus 2 square root of 6. And we're looking at the lengths of triangles, so it has to be the positive one. All right, so when you're doing these, let me see if I can just get those fractions off of there real quick. See if that would help us write it without it adjusting. Okay. So when you're doing those, sine should be opposite over hypotenuse, but I haven't labeled an angle for you, so I need to tell you which angle to focus on. So let's suppose we make theta this angle right here. If we do, then you wind up having 2 square root of 6 being the opposite side. 1 is the adjacent side, and since 5 is across from the 90-degree angle, that has to be the hypotenuse. So your sine of theta should be 2 square root of 6 divided by, let's see, 5. Okay. All right, cosine of theta should be the adjacent side divided by 5. So that would be 1/5. Okay. And then tangent should be opposite over adjacent. So that's going to be 2 square root of 6 over 1. Okay. And that would just be 2 square root of 6 when you simplify it. Okay. Now we do have a little bit of an irritating thing happening when we do the reciprocals here, because on a couple of them, you're going to wind up then getting a radical in the denominator. All right, so like when we do this one and we do the reciprocal, we're going to have 5 on top and then 2 square root of 6 in the denominator. All right, so we have to rationalize that. So we're going to come in and do square root of 6 on top and bottom. All right, and then we did that because square root of 6 times square root of 6 would be square root of 36. So square root of 6 times square root of 6 is going to turn out to be 6. And so this turns out to be 5 square root of 6. And then down in the denominator, we'd have 2 times 6, which is 12. Okay, hope that made sense. All right, with secant, we're going to flip over cosine, take the reciprocal of cosine. And so we wind up just getting 5. And with tangent, we're going to take the reciprocal of that. So we're going to have 1 over 2 square root of 6. Okay, which means we have to, again, rationalize. So we'll put the square root of 6 on top. And we'll get square root of 6 on top. And then this would be 2 times 6, which is 12. Okay. All right, so you want to get used to these trig ratios. You want to understand Sohcahtoa or remember Sohcahtoa to help you to get your sine, cosine, and tangent. And then you want to know that connection between sine and cosecant, cosine and secant, and tangent and cotangent. And then you really want to work on making sure you can identify the opposite side, the adjacent side, and the hypotenuse. If you can do those things, you'll be home free, okay? All right, so let me stop the video right here and we'll do another one that gets into a whole bunch of different triangles and trying to find a trig ratio that connects given information. But I like my videos to be kind of short.